In this video, we're going to prove that two triangles are congruent using the side-side-side, side-angle-side, angle-side-angle, angle-angle-side, and right triangle theorems. Remember that congruent triangles have all of their corresponding parts congruent. So all of the angles that are corresponding and all the sides that are corresponding will have equal measure. So looking at these two triangles, if we know that triangle ABC is congruent to triangle DEF, then we know all of the corresponding parts will be congruent. So we would know angle A would match with angle D. We know that they match up from our statement. Angle A and D are the first letter. So angle A is congruent to angle D. B will be congruent to E. C will be congruent to F. So all of our corresponding angles are congruent. The corresponding sides will also be congruent. Side AB will be congruent to segment DE. Side BC will be congruent to EF. And AC will be congruent to DF. So all of our parts are congruent. And remember, CP/CTC tells us that corresponding parts of congruent triangles are congruent. So we knew all of these parts were congruent because of CP/CTC. Now, what if we weren't given that the triangles were congruent? What if we weren't given all of the parts in order to prove that they were congruent? There are actually 8 methods for proving that two triangles are congruent when you're not given all of those corresponding parts. They are side-angle-side, side-side-side, angle-side-angle, and angle-angle-side. We also have 4 for right triangles. HL, hypotenuse-leg, HA, hypotenuse-angle, leg-leg, and leg-angle. So now let's talk about all of these. The first triangle postulate we have is the SSS postulate. So if the sides of one triangle are congruent to the sides of another triangle, then the triangles are congruent. So if we have all the measures of those sides congruent to all the measures in another triangle, we have enough information to show that those triangles are congruent. So we would say triangle ABC is congruent to triangle EFD by side-side-side postulate. Now we know that AB matches with EF, so that's why we have these in that specific order. We have to match up the right pieces in our congruent statement. The SAS postulate is side, angle, side. If two sides and the included angle, so the angle that's between the two sides, are congruent to two sides in another triangle and the included angle of that triangle, that is then enough information to prove that triangle ABC would be congruent to triangle EDF by the side-angle-side postulate. Notice even in the name that that angle is included between the two sides. Here we have the angle-side-angle postulate. So before we had side-angle-side where the angle was between. Now we have two angles where the side is between. So if we have two angles and the included side are congruent to two other angles and the included side of another triangle, that's enough information to show that those triangles are congruent. We would say that triangle ABC is congruent to triangle FED by the angle-side-angle postulate. Now those first 3 postulates actually allow us to prove 5 other theorems. The first theorem that those postulates allow us to prove is called angle-angle-side. Notice that the side is no longer included between the two angles like it was in ASA. So we have 2 angles in one triangle and the non-included side that's congruent to 2 angles and the non-included side in the other triangle. This gives us enough information to show that those two triangles are congruent, and then we can write the congruent statement that triangle ABC is congruent to triangle DFE by the Angleangleside theorem. The last four theorems only work with right triangles, so be careful and make sure you have a right angle in both triangles before you try and use one of these theorems. The first of these is called HypotenuseLeg, which means once we're given a set of right triangles, we look for the hypotenuse of each of those, which is the side across from the right angle. It's always the longest side of a right triangle. In this triangle, the hypotenuse would be AC. In this triangle, the hypotenuse is DF. So we have the hypotenuse of each triangle that are congruent. And then we have a pair of corresponding legs of each triangle that are congruent. That gives us enough information to prove that the triangles are congruent by the HypotenuseLeg theorem. So triangle ABC is congruent to triangle DEF by the HypotenuseLeg theorem. The next one of these is called leg-leg. Again, given a right angle in both triangles, we then look at both sets of legs of those right triangles. The legs are the ones that make the right angle. So AB is congruent to DE here. BC is congruent to EF. So we know both sets of legs are congruent in both triangles, which means we could prove these triangles congruent by the leg-leg theorem. So triangle ABC is congruent to triangle DEF by leg-leg theorem. You might notice that this theorem is very closely related to one we've already talked about. Notice that this one actually comes from side, angle, side. So whenever looking at leg-leg, know that side, angle, side is also a possibility. Next we have leg, angle. So we have to know that we have the right angle first, and we have a set of legs that are congruent, and then we have another set of angles that are congruent. That angle for LA has to be one of the corresponding acute pairs of angles. It cannot count the right angle as that angle in the theorem. Once we have a set of acute angles and the legs of that right triangle that are proved congruent to one another, we know that triangle ABC is congruent to triangle DEF by the leg angle theorem. This theorem is also closely related to one that we've talked about before. Notice in each one of these right triangles, we could talk about proving these triangles congruent by angle, angle, side. Or if the set of legs that were congruent were BC and EF, then the side would be included between the two angles. And this would be considered angle, side, angle, if that side was included. The last theorem is hypotenuse angle, where we're given, again, a right angle in both triangles, and we know the hypotenuse of each are congruent to one another, and a set of congruent acute angles in each triangle. Once we know that we have that given information, we'd be able to show triangle ABC is congruent to triangle FDE by hypotenuse angle. This one is also closely related to angle, angle, side. Now for some examples. Give any additional information that would be needed to prove the triangles congruent by the method given. If we want to prove these two triangles are congruent using side, angle, side, we'll have to show that two pairs of sides are congruent and the included angle would be congruent to one another. In part B, you're proving leg, leg. So we would need to know that those triangles are right triangles and that the sets of legs were congruent. In Number 2, we're determining which method, if any, could be used to prove the triangle is congruent from the information given. In some cases, it may not be possible, so make sure that it matches one of the methods or one of those 8 postulates or theorems that we've looked over in this video. Now, another great resource that has animations for the first 5 theorems, and even a theorem that doesn't work. You can go to this URL here or scan this QR code and go ahead and watch that video for some great extra information.